Hello guys, my name is Balkrishna Shastava and welcome to CodeWithBK. So in this video, we write a C++ program to resize an array. So before we begin, it is a request to please subscribe to my channel because out of 100 viewers, only 3 to 5 are subscribed. More than 95% of my audience is not subscribed and a subscription is very important. So please do subscribe to my channel. So let's begin. So we have to write a C++ program to resize an array. Okay. So let me explain the problem what we are trying to do here. So suppose if I have an integer array, okay, ARR1, okay, with values say 1, 3, 12, 18 and 27. Okay, and maybe you feel like adding a few more values to this so that your ARR1 becomes now, okay, 1, 3, 12, 18, 27, and you say maybe I add 3 more values, 100 minus 9, 26. Okay, so how do we go about doing this? So if I declare an array, okay, and initialize an array int ARR1, okay, value take 1, 3, 12, 18, 27. Okay, let me just write a helper method to print the array int ARR, and it takes the size of the array as well. So this method is going to print the array, if this is the array, as 1, 3, 12, 18 and 27. It prints all the values space separated within square brackets, and that's how we represent in our output. So I'm simply going to say print array for now ARR1, and let me take the size n1 as 5 values. Okay, you can do size of, you can calculate this as well, size of ARR1 by size of int. Okay, so you print n1. Okay, so we should simply get an output like this. So compile and run. Okay, that's what we get, right? Now I want to first try to reset the array variable to a new array. Okay, so if I have initialized my array like this, that's it. You cannot do any more changes to this array. There is no way you can add a location or remove a location or add locations, remove locations from this array. ARR1 is gonna remain this. All right, so if you try something like this, okay, I want to set ARR1, okay, to another array, say maybe with different values, okay, 19, 20, 190 and 34. Okay, this is not allowed. Okay, I'll just explain in the moment why. Okay, so if I compile, I get errors. This is not allowed. All right, so if I go back, I cannot do this. Okay, so if I have an array declared like this, I cannot resize it. Suppose if I take another integer pointer int ARR2 and I set to ARR1. All right, so this ARR1 variable, this is also an integer pointer. Okay, but you cannot change the value of this pointer because you have declared an array like this using square brackets and you have initialized it to this particular array. So ARR1 is going to point at this array. And when I say it is going to point at this array, because this array variable basically stores the address of the first location, okay, where the first value is, or you can say this is the base address of the array, right? So this points to the first location in the array, right, and you cannot change it. And this is an integer pointer too because this has a address. Okay, so if you take another integer pointer, you can set it to ARR1 because this is also an integer pointer. Okay, now if I try to print using ARR2, okay, the same number of values, I get another output of the exact same array. Okay, because behind the scenes what happens is, if you do something like this, okay, so if this is my memory, okay, you have this array allocated, okay, 1, 3, 12, 18, 27, and ARR1 is pointing to the first location of the array. This is also an integer pointer. Okay, the only thing is you cannot change the value of this array. It just points to this array now because you have declared it like this. Okay, this is the C style array. Okay, so you can say C style array. Okay, because C++ inherits all properties of C language as well. Okay, when you say int ARR2, okay, equal to ARR1, so this integer pointer basically points to the same place where ARR1 is pointing, so it points to this array. Okay, ARR1 is pointing to the first location of this array, ARR2 also points to this first location, but since this is not declared as a C style array, it is just a pointer, it can point to another array as well. Okay, I'll just tell you how. So let me just take another pointer arr3, okay, points to arr1. Again another pointer, okay, pointing to the same array. I'm going to print, so let me just say cout arr1, okay, cout arr2, okay, and cout arr3. These all three point to the same array. This has been initialized using a C style array. These two are other integer pointers pointing where the arr1 is. Okay, so if I compile and run, okay, all three give me the same array. Okay, if I change the values in the initialization, say maybe add 89, 34. Okay, so once you are initializing the array, you can add as many as values you want. Okay, but once you are done with this, you cannot change array this arr1 is pointing to. Okay, so now if I compile and run again, I get the same array for all the cases. Okay, right, so let me just put back the original values. Okay, so again in behind the scenes what is happening is, this is your first variable, this is another variable. You took another int arr3 that points to again the first location of this array. So when you print using arr3, okay, you get the same output. Okay, now I will say int arr4, I declare another C style array. Okay, but with these values. Okay, okay, 1920, 190, 30, any new set of values. Okay, and I say calculate the size as in n4. Okay, arr4 by size of int. Okay, and I print array. Okay, arr4 passing n4, and this is arr4. Okay, all right. So when I run this, I get values for arr4 as the ones that have been initialized. Okay, all right. Behind the scenes what is happening is, there is another array of 4 locations that we took, and we gave it values 1920, 190 and 34, and the variable pointing towards it is arr4. Okay, now this is going to point to the first location of this array only, you cannot change it. All right, now what we do is, I do, instead of arr3 pointing to arr1, I say arr3 is now pointing to arr4. Okay, and when I print arr3 again, okay, and I pass n4 because it is pointing to arr4. Okay, so compile and run, arr3 is now this, it was previously the arr1. Okay, because behind the scenes it was pointing to this, it is no more pointing to this, it is now pointing to the first location of arr4. Okay, so we can use int pointers, okay, arr3, arr2 to point to an already initialized array. But if I try to do, say, arr4 is arr2. Okay, so if I compile, array type int4 is not assignable. That's what I said. Once you set the array, it has been set. Okay, so this was basically to introduce that this is a C style array. You cannot add locations, remove locations from it. Once you do this, arr1 is going to point to it, and you cannot reset arr1 to or this array variable to another array. You can, however, use pointers to point to the same array. Okay, okay, because these are integer pointers. Okay, so how do we go about resizing? So C++ provides the new keyword, just as in Java, to create an array using an int pointer. Okay, that you can reallocate. How? So I say create an array using new keyword. So I say int pointer arr5, taking a new variable using the new keyword, creating an array of size 5. Okay, so int n5, the corresponding size is 5, or you can say int n5 first. Okay, and you can create an array of this size. Okay, and when we print this array arr5 with this corresponding size 5, we get only zeros. So if I have arr5 behind, okay, clear, compile and run. Okay, arr5 are all zeros. Okay, by default all locations in an array is 0. All right, we can set the values in the array. Okay, arr5 of the 0th index is, say, maybe 10. Okay, and similarly we can do for the other 4 locations, 1, 2, 3, 4. So 30, 120, 180 and 270. Okay, now when I do my second print of arr5, you get the 5 values. So okay, first you get all zeros, then you get these 5 values. Okay, right? And there is a way you can allocate and initialize using new keyword in the same line, we will see at the end of the video. Okay, so using new keyword you can set arr to another array. You can say set arr5 to a new array with size 10. Okay, you say n5 is 10. Okay, you change the size and you say arr5 is now pointing to an array of size 10. Okay, and when you print the array you get all zeros. Okay, compile and okay, we get all zeros. Okay, arr5 is now allocated to a new array of 10 locations. Now what is happening behind the scenes? Okay, so if I extend my memory, so because memory is very big, okay, so we did arr5 pointing to an array with 5 locations. Okay, so when we created this array it was something like this: index 0 1 2 3 4. When we did this, arr50 is 10, so this becomes 10. When we did this, arr51 is 30, this becomes 30. Then we do second index 2 is 120, so this becomes 120, then 180, and then 270. Okay, all right, and then we printed this. When we did this, okay, what happens is a new array of size 10 is created. Okay, indices 0 1 2 3 4 5 6 7 8 and 9. arr5 was pointing to this array, it now points to this array. Okay, this is allowed and this is how you can resize. All right, then when you print this you get all zeros. All right, problem here is 1. Okay, we lose original values. Okay, so 10 30 120 180 270 is all lost because it is all here in this previous array. When you create a new array it has all zeros. Second is memory leak. Okay, that is, you have somewhere initialized, there is a memory taken for this array, 5 locations of integers, but it is not accessible anymore. Okay, that is, you are using this memory but you cannot reach it, so this is a memory leak. Okay, and this is something that you should never be doing when you are working with C or C++. Never be having memory leaks. Okay, so how do we fix this? Okay, because our original question was if we want to add 3 more locations, say 3 more values, we should be getting something like this. Okay, cannot do it with a C style array, not possible. Can do it with a C++ style array when you use new keyword. Okay, all right, so how do we first do not lose original values? So for that what we can do is, okay, let me just write a function. I'll say int resize takes the original array arr, okay, takes the original size and takes the new size. Okay, so what to do is create a new temp array with new size. So you say int temp is new int new size. Okay, ns is short for new size. Okay, copy all the n values from arr to temp. So for int I equal to 0, I less than n, I plus plus. Okay, okay, so temp of I is arr of I. Okay, and then return temp, return temp. Okay, so let me just comment this. Okay, I will set n5 to 10, the new size, and I will say arr5 is now resize by passing the original arr5. Okay, passing the original size which was 5 and the new size which is n5 which is 10. Okay, and when you print this, okay, we see we get the original values retained with the 5 extra locations. Original values retained with the 5 extra locations for arr5. Behind the scenes, what's happening? Okay, all right, so let me take more memory now. Okay, so when we are here, okay, arr5 is pointing to this, so I'm going to redraw this. Okay, so arr5 pointing to, let me just separate memories now. Okay, so I'm just redrawing this arr5 pointing to this. Okay, 10 30 120 180 and 270. Okay, arr5 is an integer pointer, okay, pointing to this array created using new keyword. Okay, and that's all the 5 values we have set. Then you set n5 to 10 and you say arr5 is resize arr5 with original size 5, new size 10. So you call this function, okay, this line is executed. This line is executed, that is a temp array is created with 10 locations. Okay, indices 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, this is this line of code. Okay, then you copy all the values from ARI to temp, okay, for all n values. So n is 5 in this case. Okay, n is new size is 10. Okay, this is of new size. So you copy 10 to location 0, 30, then 120, 180 and 270. Okay, so indices 0, 1, 2, 3, 4, 0 to less than 5 are all copied into 10. Okay, this for loop is executed. Then you do return temp. When you do return temp, this value is returned. Okay, return type is int pointer here in ARR5. That is, you are setting ARR5 to temp, that is, you are setting ARR5 to this, and ARR5 is no longer pointing to this. Okay, just as in the previous case here. Okay, but here we were losing the original values, here we are keeping the original values because we are copying the values from ARR to temp before we set ARR to the new array type. Okay, after the function returns, we lose access to this variable. Okay, but we can still access this array using ARR5. This variable is gone. When the function returns, this is still a memory leak. Okay, because this array is still there, we have not yet deallocated the memory, we have not yet freed the memory. ARR5 is pointing to this new array. Okay, so we have fixed the loss of original values. How do we fix memory leak? Is basically, okay, delete the old array. You should always be freeing the memory, always be deleting the array when you are creating an array using like this. When you create array like this, you don't have to free the array explicitly, that is taken care of. But when you create an array using new keyword, you should always delete the array that you have created. So in this case, we are deleting ARR, okay, because you created ARR5 using new keyword here, which we passed here. So this variable gets ARR5 pointer address. Okay, so you say delete ARR. And you should always remember, when you create an array using new keyword and square brackets, you delete with square brackets in between. Okay, now when you do this, this delete ARR line will free this memory. Okay, and your array is now pointing to this. So we were able to keep the original values and take care of memory leaks as well. And this is how you should be resizing your array in C++. Okay, all right. Okay, so you have a function that takes the original array, returns the pointer to the updated array, takes the original size and takes the new size that you want. Okay, you can also pass the set of values you want to be added to this extra locations added, but that depends upon you, right? This is the code that will help you to resize an array. Obviously in C++ you can use vectors as well. You don't have to necessarily use resizing arrays, but this is just a concept, and there are certain points where you just have to use an array and you have to resize it. Okay, and we did this using integers. You can do this using strings as well. So I can say same idea using resize str. Okay, just takes strings pointers everywhere, string, okay, and returns a string pointer. Okay, so if I have ARR6, so I'll have to create ARR6. Okay, so I told you, you can allocate and initialize in the same line, because here we are allocating the array, but here we are setting the values. So you can do something like this: new string, the same way we did for integers, right? Is equals to new int. Okay, pass the size. I say int n6 is say 5. I'll say n6, and then you pass the values you want this to be initialized. Okay, so I'll say 5 strings. My name is Balkrishna Srivastava. Okay, all right, so we are gonna compile, and we have to use C++11. All right, compiles. So you can create an array and initialize it with values in the same line. So let me just print this first. Okay, so I have to change print array, okay, to print strings. Now print array str, I'll say string arr. Okay, everything else remains the same. So I'll just copy this and print. Okay, print array 6, pass n6 arr 6 and print array str. Okay, so compile again and run. Okay, my name is Balkrishna Srivastava, the way we expected. Okay, so if you had to create an array and initialize it with these values. In the same line, you could do something like this. So you, instead of this, okay, you could have done, okay, and the set of values, which is 10, 30, 120, 180, and 270. Okay, and we don't need this. Okay, and we don't need this. Okay, creating an array of size n5 with these values. Okay, so compile and run. So this extra output is not there, everything else is there. Okay, because when we create ARR5, it is with the 5 values, then we resize it. So now we resize a string array. So you can say ARR6 is resize str, pass ARR6, pass old size n6. Okay, and you can say add 3 more locations, so n6 plus 3. Okay, so n6 plus equal to 3. Okay, all right, then we print again, clear, compile, run. Okay, the locations are all blank, so that's why you cannot see it. So if you want to say set maybe of index 0 1 2 3 4, so 5 is welcome. Okay, to code with BK. Okay, 6 and 7. Okay, so compile and run. You see, we had 3 more locations, okay, to the same array. All right, and after we are done with the arrays, you should always delete the array. So I'll say delete ARR5, and we also delete ARR6. Okay, once more, clear, compile and run. Okay, everything works fine. Okay, all right, so there is one more C style way to resize an array. That is, if I take another pointer, okay, int ARR7, and I allocate it using malloc. So I have to use cstd_lib. Okay, I say I want a type of int pointer, okay, malloc, okay, size of int into, what is the size? I can say int n7 as a 6. Okay, so give me a memory equal to size of an integer into n7. That is, give me memory to hold n7, that is 6 integers. Okay, and then I can say print array ARR7, ARR7 and 7. Okay, print array. Okay, so clear, compile and run. Okay, 0 values. Okay, so let me just set maybe a few values. I'll say ARR7 of 0 is, say, maybe 90. Okay, 0 1 2 3 1 2 and 3. Okay, or maybe locations 4 and 5. Okay, 90 minus 5, 89 and 189. Okay, so clear, compile and run. You will see the values now. Okay, we set index 0 1 2 3, we skipped, so it stays 0 4 and 5. Okay, so we can reallocate using realloc. That is, I can say, I take this here, I can say AR7, okay, is realloc. Okay, and what is the new size I want? I want to reallocate AR7, and what is the size? I want, say, 3 more values, so n7 plus 3. So I'll say size of int into n7 plus 3. Okay, and you also have to cast the pointer, because the alloc returns a void pointer. Okay, right, we do n7 plus equal to 3 and we print the array. Okay, so you will see 3 extra locations. So clear, compile and run. Okay, 3 extra locations, and we have all the previous values intact as well. And that's the thing with reallocate. If you are using the same pointer to reallocate, you have all the original values intact. Okay, 3 more locations. If I do this like 5 more locations, and I say plus equal to 5. Okay, so clear, compile, run. Okay, 1 2 3 4 5 more locations. Okay, but this is very C style, so if you're not comfortable, you can always use new, right? And you should always, again, free memory after you use it. Okay, So for new we use delete, for malloc we use free. Okay, so clear, compile and run. Okay, all right. So this was your C++ program to resize an array, right? So I hope you like this video and this video was helpful. So if there is any doubt, there is a part you do not understand, please let me know in the comments. I always try to answer all your comments. And you can always let me know in the comments if there is a question you want to solve or if there's a concept you want to discuss. So please like this video, subscribe to my channel, and thank you for watching.